All right, it's time to get mad and talk about how we use the mad. So this is a set of data points that I pulled up. We could take a minute and find the mad for each of them, but for the sake of time, I'm just going to tell you the mad for each of them. The mad for this first one ends up being 2. These are paper airplanes that are thrown. Airplane 2 has a MAD of 1.45, and airplane 3 has a MAD of 1. Now we can kind of see that a higher MAD means more variability. Or more spread. The data is spread out over more values. And the one with the lowest MAD, you can think of this as the least variability and most accurate. Now, this image also shows a way that if you're given a dot plot to find the MAD, since I know the mean, I can just write down how far each of these is from the mean, as you can see in the first one here. But this is why we talk about the MAD, is it helps us discuss not only which airplane flies the farthest, but which airplane is the most accurate. And so sometimes knowing which one is the most accurate, the one that is most reliable, can be helpful. Sometimes we want something that is more reliable with a smaller mean, or larger mean depending on the context, than something that has a more favorable mean but has more variability. For example, if you think of this as how long a light bulb lasts, maybe a light bulb lasts for 15 years but has high variability, whereas a light bulb that may last 13 years has 13 years on average has low variability, which might make it more favorable.